In this video, we are continuing our midterm review and focusing on consumers and producers surplus. So the example I want to look at is the following. Suppose a store's daily demand equation for a new item is Q equals 40 minus 0.1 P squared, where P is the unit price and Q is the daily item sold. If the store charges $10 per item, what would the daily consumer surplus be? So like with all of these midterm review examples, I want you to begin by pausing the video for about 3 minutes to try this question on your own first. It's likely not going to be enough time to finish the problem, but I want you to be thinking about what are the key ideas? How do we begin and get started with it? So 4, 3, 2, 1, pause that video. Pause it for 3 minutes to try this. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 3 minutes. So remember, consumer surplus, which I'll call CS, is an integral from 0 to Q bar. Q bar is the number of items that end up being sold at whatever price they end up charging for the item. Okay, and then the function in the integral is the demand function, d of q minus p bar, where p bar is the price that ends up being charged for it, dq. Alrighty, so to begin us off with this, we actually know what p bar is, what the price is. It tells us it's $10. And if we know p bar, I can plug that into my demand equation to figure out q bar. So if we did that, we would get that q bar is 40 minus, so 0.1 is 1/10 times 10 squared. So this is 40 minus, and one of the 10's cancel, and I'll get minus 10, and that's 30. Okay, so I know Q bar. So the only thing that I need to think about now is, well, what is my demand function? What is d of Q? Well, to write d of Q, I need to isolate P in the demand equation. Because the notation d of Q means, well, what's the demand equation in terms of the variable Q? But right now I have my demand equation with Q isolated, so it's in terms of P. So it's the opposite of what I need it to be. Okay, so we need to isolate that P, so let's rearrange stuff. I'm going to move the negative 0.1 P squared to the left. So I'll get positive 0.1 P squared. And let's move Q to the right. So this equals 40 minus Q. And then I can think of 0.1 as being 1/10. 1/10 P squared equals 40 minus Q. And now I can multiply both sides by 10 to get P squared equals 400 minus 10Q. And then if I square root both sides, we get P equals, when I square root both sides of an equation, I need a plus or minus square root of 400 minus 10Q. But in my problem, I can't have the negative square root. That actually doesn't make sense, because P is a price, and if I had a negative square root, we'd be saying the price can be a negative value, which doesn't make sense. So P can't be negative. Ooh, whoops. Okay, sorry about that. Yeah, it would just be weird for the business to be charging a negative quantity. That would be like the business is paying people to take this away, which is unrealistic. So I'm going to ignore that possibility. So we just have P equals the positive square root of 400 minus 10Q, and that is my demand in terms of Q. That is my d of Q function. So we're ready to take that and plug it in for d of Q in the integral. So our consumer surplus, CS, is the integral from 0 to 30, that was Q bar, of our demand equation, which was 400 minus 10Q. That's what it was in terms of the variable Q. Minus 10, that was the value of P bar, our price, dQ. So now we have to think about, how do we do this antiderivative? At this point, I want you to if you didn't quite get this far, pause the video for about 1 to 2 minutes to try it from here and see if you can make progress with this integral. 4, 3, 2, 1. Pause it one more time to try it from here. Alrighty, so hopefully you did that. Let's talk about it now. So with this integral, we want to split it up into two pieces. 0 to 30 of the square root thing, 400 minus 10q, and then minus the integral from 0 to 30 of 10. And the advantage of doing that is the second integral is much easier to do. The antiderivative of 10 would be 10q. I would need to plug in 30 and 0. And that's easy enough to do. If I did that, I would get 300 minus 0, which is just 300. Okay, so that second one is not too bad. So with this first integral, we can do this using u substitution. So if I let u be equal to the stuff inside of the square root, 400 minus 10q, du would be negative 10, and I have to write a dq at the end. So if I isolate dq, du over negative 10 is equal to dq. And then because I have these limits of integration, I'm going to convert those to u values. Right now they're in terms of the variable q. So if q is 0, that bottom number, and I plug that into my u substitution, we would get that u equals 400 minus 0, which is 400. And let's do the same thing for that upper limit of integration, which was 30. If I plug that in, we'll get u equals 400 minus 10 times 30, which is 300. And subtracting these, that's 100. Alrighty, so we are ready for this integral right here. So this ends up becoming, so let's see, the 0 changed to 400. And the 30 changed to a 100. And then inside of the integral, we'll have, whoops, I forgot something. Okay, I forgot to write a dq on this integral. That's right, so we always need that notational thing on these integrals. Alrighty, so we have square root of u, and then what was dq? It was du over negative 10. So from here, it's not too bad. We've done the hard part of this. Let's see, we can take that negative 10 and factor it out, bring it out in front. We get negative 1/10. And now we're ready to do the antiderivative of square root of u. So let's see, that's reverse power rule. This will give me u to the 3/2. And then I divide by that 3/2. So that's the same as multiplying by the reciprocal, multiplying by 2/3. And then I need to plug in 400 and plug in 100. And I'm going to skip the computation here. But if you did that, what you'd end up getting is 1400 over 3. So now we know the values of both of these integrals. So we can write our consumer surplus, CS. So the first integral was 1400 over 3. And we add to that the second integral value. So for the second integral, remember, we had this minus sign. So actually I need a minus. And then it was 300. Okay, so we could get a common denominator to evaluate this. So let's see, 300 is 900 over 3. All right, so 1400 over 3 minus 900 over 3, that is 500 over 3. And the units of this are going to be dollars. So those are the units of money in my problem. And that is my consumer surplus.